Hi guys and welcome. Today we'll be talking about linear, quadratic, and exponential models. In other words, you're given a bunch of points. What are you dealing with? What kind of model should you use? Should you use a linear, a quadratic, and exponential? Okay, so there's a couple ways to see. Number one is graph the points in a coordinate plane and see which model they resemble. Okay, so for example, you just take your points and you just graph them in the coordinate plane. Okay. And if they appear in a linear fashion, you're probably dealing with a line. Okay, something that looks like this. Something that you can draw a line straight through. Or, okay, if you're dealing with something that when you graph it, it goes up a little like this. Let me move this one over so you can see a little bit better. But then it also has symmetry on the other side. Something that goes up like that. So that would definitely be quadratic because it's going to take the shape of a parabola. Okay? Or something that is exponential. Okay? So it kind of goes in downward path. It kind of looks like half of a quadratic, but then you look at the other side, you're like, that really looks exponential. So that's the model that you will be using. Okay? So if you are using the straight up linear model, you'll be using this formula right here. If you're using the quadratic, you'll be using y equals ax squared plus bx plus c. And if you're using exponential, it will be a times b to the x. Okay? And so those are the different models you'll be using and just working with them. Okay, now you can also look at the differences in tables and see if there are constants or what to decide. You can decide which model to use there. So you can actually take a look at it. So if it is a linear model, first difference is constant, and it's plus or minus. You're adding or subtracting. Now if it's a quadratic model and you're just looking at the table, alright, so now when we're looking at a quadratic model, okay, we will be looking for the second difference to be constant. And it's a constant plus or minus. It's probably going to be plus. So you're constantly adding to it, okay? Now exponential models, they use what is called, you are going to be using the common ratio. In other words, it's instead of an adding or subtracting, you're multiplying or dividing. Okay, so that one's pretty straight up simple of working with it. So if you're always multiplying to go to the next number, it's definitely an exponential model. So you definitely know which formulas to use depending on whether you're graphing it or just taking a look at the table of information. Okay, now what we're going to do is we're going to actually be able to take a bunch of information and actually take a model of information and then be able to figure out what the actual formula looks like just from the table. Okay, so what we're going to take a look at is the information first. So as you can see on this side, this is just the table. I'm not going to graph it as much. You can graph it and be able to see it. I'm just going to show you how to do it algebraically real fast. As you can see, you're increasing by 1 each time, so that's pretty simple. So that's pretty nice. Okay, now on the y side, that's where the information really does come into play. So let's take a look at it. Okay, that's a difference of 1.5. You know what, this one's off a little bit. Let me change the 31.5. We'll keep that one right there for a sec. Alright, so let's look at the differences here. So this one we are going up by 1.5. Okay, and then this one we are going up by, I believe that's 3.5. And then this one we are going up by 7.5. Okay. And then this one we will be going up by 9.5. So plus 9.5. Alright. And so I was actually doing the wrong one. So this one should be going up by 11.5 because it looks like we're increasing by 2 each time. Okay, so this one should be 35.5. There we go. Okay, so right off the bat, that's not constant. So what we need to do is look at the second difference. Now, also, it's not constantly multiplying to get up to another number. I can't see it if you can. Okay, but this one's going up by plus 2, plus 2, plus 2, plus 2. Oops. Okay, and you just keep going up by 2's. So this is going to tell me this is a quadratic model. So this is ax squared plus bx plus c. Okay, now to get all the numbers, we're going to have to fit it in and just work with it right here. Let me get it real fast. Okay, so first off, the y-intercept is going to be pretty easy to get. The y-intercept is definitely going to be here at 0, so that means this is going to turn into the 0 and just be pretty simply set up like that. Okay, all right. Okay, so what we're going to do is we're going to set up 2 sets of points with this. Now, just for sake of just using whole numbers, I'm going to use these two, 4, 24, and 2, 6. So what I'm going to do is I'm going to plug it in. So this will be 24 equals a times 4 squared plus b times 4 plus 0, because that's c, obviously. Okay, and then the other part is going to be 6 equals a times 2 squared plus b times 2 plus 0. Okay, now this is going to look pretty confusing at first, but what I'm actually doing is I'm setting up a systems of equations to solve for what a and b are going to be. I already know c is going to be 0, so that one's pretty set. So if you notice, I'm going to have 24 equals 16a plus 4b, and I'm going to have 6b equal to 4a plus 2b. Okay, now if you notice real fast, if I multiply the bottom part by -2, okay, I'm going to get an equation where if I add it with the top part, I'm actually going to be able to cancel out stuff. So let's go ahead and speed up to the next step. Okay, so I distributed through the -2, okay, and what's going to happen is when I add everything together, this is going to be 12 equals 8a, okay? So that's really cool because I'm going to get 2 is equal to a. Alright, now if 2 is equal to a, I can plug that back in to find out what b is going to be. So I'm going to take this 2 and plug it in, and it doesn't matter which one you use. I'm going to probably use this one. Okay, so now I get 24 equals 6. Well, 16 times 2 is going to be 32, so 32 plus 4b. Okay, I'm going to minus that from both sides, so this is -8 equals 4b. So I minus 32 from both sides. Okay, so I minus 32 from both sides, and now I'm going to get -2 equals b now. So now that I have all 3 letters, I can actually model this out, and this is going to be y equals 2x squared minus 2x, and then I don't even need the 0 on it, and I have everything all set. Okay, and that's how you model this stuff and work with it. Now, are you going to be given a lot of tough problems where you actually have to do it this way? Not a whole bunch where you have to actually do this, but you do need to know how to actually model the information and be able to solve it. And the majority of the time, using a system of equations is the best way. Okay. All right, that is it for working with linear, exponential, and quadratic models. I will talk to you later. Bye.